Hello, welcome to BackToCoding. If you're a beginner looking to delve into the world of design patterns, or someone wanting to polish their skills, you're in for a treat today. We're going to explore the factory pattern, and not just in theory, we have Kotlin and Android examples lined up for you. What is factory pattern? In simplest terms, factory pattern is a design pattern that allows us to create objects without specifying the exact class of object that will be created. Think of it as a creator of objects. Now, let's see some code. First, we will see Kotlin examples. In this example, we are building a simple vehicle system. The vehicle interface serves as a contract for any class that wants to represent a vehicle. By contract, I mean a set of rules or methods that any implementing class must provide. Car and bike classes are concrete implementations of the vehicle interface. Both classes must provide an implementation for the drive method. Here's where the magic happens. The factory pattern's main goal is to abstract the creation of objects. Instead of directly using constructors, we use a dedicated factory. The vehicle factory provides a method called createVehicle. This method returns an instance of the vehicle type based on the given string input. We're using our factory to create car and bike objects. Let's see another example. This is a slight variation of the factory pattern where the factory itself can be parameterized. Just like our vehicle example, we define an interface for all shapes. Both circle and rectangle classes implement the shape interface, providing their own implementation for the draw method. Instead of having a static method, the factory is now instantiated with a type and then used to produce shapes of that type. Let's move on to Android examples now. In Android, dialogues are used to show messages to the user or to get some input from the user. But creating a dialogue involves some repetitive tasks. To avoid repeating this process every time you need a dialog, you can use the factory pattern. Class Dialog Factory declares a dialog factory class. It's like a blueprint that tells Android, hey, I'll be creating some dialogues here. Inside the class, we have a function named createDialog. It takes two parameters. Type, a string that will tell the factory what type of dialog to create. Context is like the current state or situation of the application. Dialogues need to know where they will be shown, and context provides that information. The function returns $dialog, which means it returns an $dialog object, or null if the type doesn't match any dialog configurations we set. The when statement in Kotlin is similar to a switch statement in other languages. It lets us execute different blocks of code based on the value of type. If type is error, we construct an dialog using the dialog.builder class. The builder pattern is another design pattern that's used for constructing complex objects. It's a way to set up the dialog step by step. We chain several methods to the builder. setTitle sets the title of the dialog. setMessage sets the message that will be shown in the dialog. setPositiveButton adds a button to the dialog. OK is the text on the button. The second parameter, null, would be a listener to handle clicks on the button, but here we don't need to do anything when the button is clicked. Create, finally, this creates the dialog object with all the settings we've added. If type is info, we start creating another dialog. This chain is almost identical to the error dialog, but with different text. The dialog created will inform users rather than warn them of an error. If the type provided doesn't match error or info, the function returns null, which means no dialog will be created. Let's see one more final example. Intents are messages that allow you to pass information between the different parts of your Android application, and even between different applications. The intent factory class will handle the creation of these intents. The createIntent function, like createDialog, takes context and type as parameters and returns an intent object or null. The context is used to see where this intent starts, and type decides what kind of intent to create. We use a when statement to decide which intent to create based on type. If type is details, we create an intent to start details activity. If type is settings, we create an intent to start settings activity. Like the dialog factory, if type doesn't match any known value, null is returned. In both examples, the factory pattern helps you create objects, dialogues, or intents without having to sprinkle creation logic throughout your app. You define it once in the factory and then reuse that logic wherever you need to create those objects. This simplifies maintenance and improves consistency across your app. The factory pattern can seem daunting initially, but as you've seen, it provides a neat way to abstract object creation, making our code more modular and manageable. Remember, it's not just about understanding the pattern, but knowing when to use it. Want more deep dives into design patterns? Hit that subscribe button, give us a thumbs up, and share this with your fellow coders. This is Back to Coding, helping you make coding simpler, one video at a time.